So hi, I'm Soumya. I am the Our Ladies New York founder. I'm on the RN Finance Committee. If you guys are free in May and want to come to a finance conference and R specifically, come out to Chicago. I'm a quant in the public sector in finance. And so very recently I started down the road of open source contribution. So you can sort of see my challenges as I go through my problem today. My disclaimer. All the views are in this presentation are at your own risk and also not representative of my employer at all. And let's keep talking. Here's my email and there's my Twitter handle, or you can just find me afterwards. So when I first began interacting with the data science community, which is like 2-3 years ago, the two things became really painfully obvious. One was I had a lot to learn, and I needed to learn tools, packages, and things that were being introduced in a really fast way because they were just getting improved upon so quickly. So of course this led to more questions, right? That how do I do this? How do I actually build this data set or build this data science skill set? And how do I manage to do this while working in my day job because I have a pretty heavy workload. So where could I begin? And so this led down my path. So the idea was, the first piece of advice that I got from a lot of people was like, hey, start contributing to open source. That's the way to do it. You can showcase your skill sets, you can learn things. And so my elaborate plan was like, I'm gonna spend a few months becoming a perfect R programmer. I'm gonna know everything out there until I'm comfortable with it. And I'm gonna build like amazing projects, like, from, I don't know, all those like really amazing, awesome projects I read on the Medium. And then I was gonna actively be a contributor. So none of that actually happened. I wish it did. But the reality was I just should have started right away and just taken small piecemeal problems that I thought that were interesting and started working on it, or data sets that I found interesting. And so that's exactly what I did. So my initial emotions were contributing to open source is absolutely terrifying. There's an imposter syndrome where you think that only experts do it out there, and there are some experts in the audience. And where do I actually start? So hopefully I can answer some of these for you today. And again, I said, try to solve an interesting problem that you relate to. Okay, so my problem that I had to relate to was understanding the real estate market. Oh, and the reasons why I wanted to do this was, one was that it's just a really cool data set. It has a lot of different applications, and it can be, you can make a lot of innovations in how you think about real estate markets, especially because they're geographically so different if you look at different markets, and there's a lot of different types of analysis you can do with it. And then it would empower myself to also make better financial decisions as a woman. We should do a better job saving ourselves. And so this was one of the things to like become more diversified. And maybe one day it would help me find a home with a large enough closet. So that was my motivation. And to share with all of you was to start building and sharing my work, as well as start learning this way about other ways to do analysis. So in my day job, I do a lot of time series analysis because it's all finance. So I don't get to work with geographic data necessarily, because I don't do really cool trading in finance. So this was a great way for me to start practicing those skill sets. Okay, so when I started looking at real estate data, the first thing that comes up is like, hey, how would I classify real estate data, right? I need to have some demographic and geographic information. So I begin with first looking at the census data. That's the most publicly available data set. And there are 100 censuses, surveys, and programs that are done by the American Census Bureau. And so you can look for all of this on their website. And so I'm just gonna quickly go through the 5 most popular census programs. So one is the American Community Survey, which is like the level above blocks. I had a diagram, but I think I took it out. So, and then they have the lowest level at blocks, and there's county level data, and then there's a survey of business owners, and there's an international database. Really, you want the level above blocks because blocks are even below zip codes, so you want it a little bit higher than that. So that's why I chose the American Community Survey. And that's essentially, they have different versions of that. So they do it every 5 years, every 1 year, and the more comprehensive version is every 5 years. So that's the data set I've chosen. So it's a nationwide survey. It's done to look at demographic and housing, socioeconomic information. And there's an annual sample size for this that's always at least above 65,000 people, and it's for 3.5 million addresses, which is kind of significant because you want to take a big data set to really make relationships and understand what relationships are. And so this last survey was done between 2012 and 2016, and as I said, it's a 5-year. And so it's from the beginning of the year till the end of 2016. And it's just the most thorough, so it's just a great way to begin. And so how did I get this? So I primarily work in R. I think I said I was an R lady. So so that's where my natural tendency was to go to start pulling census data into R. There's a lot of blogs out there that even talk about this stuff. And so the first thing I did was like, hey, I work in the tidyverse. Why don't I use a tidy package? And I'm sure there must be one because there are lots of people at RStudio that just build amazing things. So there is a tidy census package out there, and that's what I decided to work with. So the other side of the data, once you have census data, is you need the actual information about housing and what's out there and what types of housing markets are out there. So the first thing I did was pull from MLS. So I don't know if you guys are familiar with this at all, but MLS is the multiple listing service data, which is actually data put together by real estate agents and real estate brokers. And it basically is and they collect all this data and enter it themselves manually. And only real estate brokers have access to this. So it's, as I said, it's spread across like 700 regional databases, which is nuts. There are not that many public APIs that really allow you sort of composite access and like give you, there's a lot of data cleaning you need to do with this because it's really messy data. And they restrict membership, and there's definitely no standardization across different geographic regions. So it's a nice dirty data set to play with. And so today for our analysis, as I said, because the census data is available at zip code level, we're also going to look at this at zip code level. And again, how did I get this into R? I pulled this from a third-party vendor called Clear MLS. So this is why I don't take responsibility for what his data looks like, and I think neither does he in his service agreement, which is great. So, so we can all just play with this data. So you have the big, if you've heard of, when you think of real estate data, you probably thought of like Zillow or Redfin or Trulia, and they provide a lot of estimates, but none of them actually have access to all of these individual MLS databases across the universe. So, so MLS is actually the most accurate. So if you're trying to look for real estate, like actual homeowner information over time, that's your best bet. And I think some people, I think some of these companies, if they have like MLS data in certain areas, they release it like on Kaggle. I think a while back folks released it. The other types of data that you can also look for is for sale by owner. So this would be directly posted by an owner. It doesn't go through the MLS database, so this is things missing from the MLS world. And they usually sell for less, so there's a very small percentage of the market that actually does this. I think it's like 8% of all of the real estate market is like a for sale by owner. So you're not missing that much of the market if you just use MLS. And then this is the other caveat. In large markets like New York or I think San Francisco it's as well, people can actually use Sotheby's or Douglas Elliman and they can bypass the MLS database anyway. So that's sort of just to keep in mind that there are one or two other areas and this data is really disparate. So just to give you an idea of the packages I used to do this analysis. So for me, this was a challenge because I never worked with shapefiles before. So I got to work with Leaflet, Viridis. These are all sort of, Viridis is a color package, but Leaflet, I'm not going to pronounce all these. But yeah, these were allowing me to pull in JSON files and then doing some geographic mapping. The finance package I'll show you just simply, that's just how to do some amortization estimations and also just to estimate your cash flow. And then obviously I use the tidyverse a lot and dplyr, so that's the data science part of the world. So yeah, so I decided to, since I live in New York, I decided to actually look at historical data in New York. And so that's where I started. So the first things that I came up with was like, hey, I have a bunch of questions, right? I have this data and I have these two places where I can use this data, but let me think about what I actually want to do with this. So the first question I have is, okay, well, what's the most in demand like borough or neighborhood? What are the hot properties in these neighborhoods? Like where should I be looking to rent or buy, or what should I be doing really? And am I living in the right neighborhood? And then there, of course, you want to explore relationships. Like you want to say, hey, are property sizes in New York versus square footage? Like, is there any relationship there that we can continue to explore? The age of buildings, how old are properties in New York for you to understand when you start renting, how much upkeep will I have to do, or maybe if you own. And also, can we just develop some metrics just to understand the markets better? So yeah, so the first thing I did was to, as I said, take this really, really dirty MLS data set that also has locational data, and I merged it with the actual sold numbers from the MLS data with the census information. So you can see I had a bunch of stuff here that actually allows you to, understand the sale type, the price, the location, the size, the year built, square feet, etc. So just to give you an idea, so when you take this and you say, hey, I just want to see what the distribution of NYC homes is, and this is across all the boroughs. This is across all 5 boroughs. You see that, hey, it's pretty. I would expect a lot of like. The max I thought was like very interesting because I removed because I first saw like a $30 million or $40 million max and I was like, that's ridiculous. Obviously that's not important. So I threw out the outliers. So now you had a more reasonable estimate of like housing that was more understandable other than the few outliers that kind of drive the price up. So this is just to give you a sense. And then again, obviously you want to look at this, in terms of, oh yeah, it's telling me to pick a bit better bandwidth. But you're looking at a distribution of this to really understand, okay, well, what does your data set actually look like? That's usually what I first begin with. So, and then the other things that you want to understand is, okay, now that you have this idea of the prices across this, obviously this could be a different set of square feet, and this could be a different set of bedrooms. So the first thing I wanted to do was understand what's the distribution across different sizes of apartments. So if you see, which I found very curious, so the sizes are at the bottom, I don't know why it says year, and then this is the sale dollars. And basically, if you see the 1 bedrooms are like, there are a lot more of them, there's more distributions of them than the 5 is like really spread out. So I'm wondering if these are like just 3 observations that like are in the Bronx or something. And I don't know. So I thought that was very interesting to show you. So as I said, this is just my journey. So none of this is like 100% accurate. So if you make investments based on all this, then that's like, good luck to you. So the next thing I decided, and as I said, I got to do a lot of geospatial sort of stuff, analysis. So I started with saying, okay, well, what do median prices look like in New York? And so median home prices in New York, like that were sold in the last 5 years. So that's what I did. I cleaned up my data set. My data set had active listings as well as sold listings, as well as I think some random listings that were just there, which I think either people pulled out of the market or whatever. So I just picked the ones that were sold and then, kind of ran through creating this using the leaflet package, which I discovered is a very cool little thing in R. So yeah, so just to show you this, and I also wanted to ask you all. So what's interesting here is if you look, you would expect, as you would expect, is that in Manhattan you have a lot of like high price neighborhoods, right? These are really expensive neighborhoods. And so yeah, I have 2 problems with this if people have encountered this before, is that leaflet and shiny, they don't do well together. Or leaflet and markdown don't do well together. And the other thing I had a question for is if anybody has worked with spatial joining files, because I had so much trouble trying to get the right neighborhoods to match. So if people have comments on that later, we can talk about it. But yeah, I thought this was particularly interesting that, Manhattan had these prices, and you'll see how this kind of evolves in the future. So median prices, this is like all of Brooklyn, and you'll see these NAs are because I couldn't actually match the shaping as well. So this is actually even more work that needs to be done in this data set. So, as I said. Okay. So then the next thing that you do is say, okay, I've seen median prices by neighborhood. What does it actually look like by borough? Because maybe I take a step back and really understand like where in the boroughs I should be living. So here are the 5 sort of boroughs of New York, right? And you would expect, and this turns out to be exactly what we expect. As in Manhattan would be the highest with the most spread out, right? With Queens and Staten Island in the middle sort of, and Brooklyn a little bit closer to Manhattan because there are a lot of prices that have been increasing in Brooklyn. And the spread is a little bit less than Manhattan, if you see, right? So it seems to be approaching 1 million in Manhattan, no matter what you do. So I thought that was pretty cool. Yeah. And so the next thing that you look at was to say, okay, now that I have an idea of like what the borough is and how expensive each borough is, then I want to see that if I buy a property, right, or if I own a property, the first thing that you want to do when you invest in something like this, or you're trying to even just rent it to understand how expensive rent is say, how long would it take me to actually pay it back, right? So your first thing you're saying is your median price to your rent ratio to say, okay, like how fast can I pay this back? And so when you're investing in a property, you want to be able to, that'll be what you actually match with your mortgage payment. Those should be generally equal. So at least at some point you're making some money. So what would our expectation be? Is that we would expect it to be faster to pay off with less expensive homes, right? Because they're just cheaper, so it'd be easier to pay them off. But what you actually find is something really interesting. So if you remember, we saw all of these areas were were really, really yellow up here. And what that means is they were like really expensive, right? The median prices were really expensive. But at the same time here, when you do this, they also rent really fast and you can pay them off really fast. So it's just because they're really popular neighborhoods that people, even though they're expensive, there's enough demand that people want to live there. So when you're looking at real estate markets, or you're trying to understand demand in certain neighborhoods, or you're trying to pick out your next business out there, you want to see that there's a lot of influx of people coming in. So this kind of gives you that intuition to say, hey, like, even if it's an expensive area, it might be worth me investing there because I can actually make my money back, possibly. So the next thing you would look at, another ratio, is to say, okay, you have median price to days on market. So how long would it take me to actually sell the place? So you'd expect less expensive sales to happen faster. Again, because it's like people can buy a less expensive home. They don't have to take an expensive mortgage out or whatever. So you'd expect that to happen a whole lot faster. And again, this is really interesting as well, is that that's not necessarily the case. So I actually had been tracking Long Island City here when I did this, and yeah, Long Island City apparently also has, like, it just moves. The days on market are still lower than what you would expect for an expensive neighborhood. So just thoughts. Okay. And so the next thing that you would say, okay, well, now that I have these sort of like some intuition around what I'm thinking, now the next thing you'd say is, okay, how can I combine it all? And here you would look at, so what I graph next is the median price to rent versus days on market. So again, here the median price to rent ratio is shown divided by the days on market. Actually, I think I show it across the plot. So again, you would expect a lower ratio would be correlated with less expensive homes and neighborhoods. So let's see if that's actually true. And this one, I wanted to show it here. Yeah. So basically this shows you, so this is actually, so the median price to rent ratio is at the bottom here. And then the actual median, the days on market is on the y-axis. So what this shows you is like, so if you look out here, which is kind of crazy, is that even though Chinatown has this like huge median price to rent ratio, which means like it's harder to get this off, the days on market is still fewer, right? So which is kind of nuts. And then I thought it was really interesting because there was like, I think there was the East Village around here, which again is or Battery Park City, which is notoriously one of the more expensive neighborhoods in New York, but it's still like a lot, it's a lot easier to actually make this inventory move faster. So really you want to look at like kind of, buying down here or renting down here. And these would be like kind of areas where you're like, okay, well, there's something weird happening. I wonder what that is. So I thought that was cool. And different ways to talk about it. And just different ways to look at it. So I thought that was really interesting as a measure. And again, this is similar to something on like balance sheets. If you guys have ever looked at like financial balance sheets, they have an asset turnover ratio. So this is an equivalent of that. So then the other thing now you want to look at is to look by neighborhood and say, hey, like obviously every place in the neighborhood is not going to be priced at the same amount. Even if I'm looking at median prices, that doesn't really give me an idea because I could find like, what if I'm like that one person that finds an amazing apartment in Soho that I turn into like a multi-million making business. So that's kind of what I looked at here, and I took 3 example neighborhoods, and I looked at Long Island City because Amazon was coming through earlier, and I thought that was cool, and I was wondering what happened after Amazon made the announcement of not coming. And then the Upper West Side as well as Harlem. As you can see, there's like a lot of spread across the neighborhoods themselves. And then I decided to look at some simple correlation plots to just see if there was anything worthwhile exploring. And I did think I think here this was pretty interesting. The unit price versus unit rent. Again, that's like you would expect that to be the case. And then I think the unit square foot versus the age, the negative correlation makes sense. But I just wanted to see how it looked across different neighborhoods. And it seems like the relationships actually hold across different neighborhoods. It's just obviously the magnitude of each correlation is different. And I think they were much stronger on the Upper West Side for all of them across than they were here. Like the unit days on market is very close to the unit age, things like that. So this is for Long Island City. So to wrap all this up is to say then, okay, well, now that I've done all these individual pieces of analysis, what will I do next? So next I want to actually understand, how can I actually make money on this? So again, it's very simple. It's what I'm going to show is a very simple equation, and real estate is not that simple a market. But it's just income minus expense equals profit. And here, so how do we build a simple cash flow model? And if you guys are familiar with doing any sort of like bond payment or bond math at all, it's very, very similar, but here just doing, it's a simple loan. I take a 5% interest rate, I'm doing this on an annualized basis, and I'm trying to understand how long this length of the loan will be, so I can actually understand what my mortgage payment is month to month. So, and I just take 360 days, and I'm taking my face value at 0. My present value is, I just took an example of 500,000, which is like an average amount that you would probably spend in New York, just to give you an idea. And then I plotted this with Williamsburg, and it looks like you actually cannot make, what does it say? Oh, sorry, I did this with Long Island City. I think I forgot to change the title up top. And basically, it looks like you cannot make any money in Long Island City. Right now, if you tried to buy this, because I chose the 10 highest properties and said, hey, if I had my annualized income and my annualized expenses, my profits just, they just don't happen. So maybe in the future. So next steps would be that I would collect and clean more data. I've actually, so I started this analysis back in November of last year. And I've been slowly getting more data sets in there. So I've been working on adding a lending data set in here. I would like to have more interesting data sets like coffee shops or commercial services, but I find that those are even harder to integrate with. As my data sets keep getting bigger, I'm wondering if I should be switching out of R and doing it in a different language. And I also expect to try building some sort of predictive component to it. But so far, I think just getting the data clean and available in a way that's useful to me has been interesting and a learning curve on its own. So I didn't have to. So one of the things I wanted to keep in mind for you as you think of doing more open source projects and you think of doing your own analysis is that I didn't have some grand big project. I just had a problem that I personally wanted to solve and educate myself with. And I learned a lot more about spatial data than I ever would have learned on my own because I never use it. And eventually this is going to be a shiny app. So keep your eyes out, maybe in a year. So if you guys decide to do any future open source contributions, I think one of the things I learned a lot from, especially when I tried to discover my data sets, was I would go to different people's packages or different analysis they had done, and I would actually look at their documentation on GitHub and try to learn of why they had done it in this way and how could I, because a lot of people haven't done zip code level analysis, so they've either done analysis with the census or they've just done analysis with the MLS data or they've pulled something from Kaggle, but working with this data specifically in this vast scale was not done. So it's kind of cool to see what other people do and how you can leverage that. And then, as I said, analysis also counts as contributions. I know there are lots of engineers out there that build amazing packages and things, but if you're not at that level and if you just have problems to solve, it's also cool when you do analysis. And yeah, the other cool thing that I discovered through this was I learned about an interesting data set that I would never have encountered on my own because I'm not a licensed real estate broker. And this just happened to be because of a conversation I was having with a friend, and I started learning more about this market. So I think there are ways you can even start creating your own data sets. As I said, like if I combine like lending data and this to see how that can be useful in the future, maybe that would be another project of its own. So what I hope you walk away with is that you're not scared of open source, and there's no contribution size that you need to do. It's not like a barrier to entry. And I hope you decide to share your hard work and lessons with others. And that's it. Okay.